This is now particularly about the binomial distribution, and you've got to find the mean and variance and then a probability. Has anybody got an answer first of all for the mean and variance of this binomial? Anybody got an answer for the mean and variance bit here? Sorry? Yeah, that's right. This bit here, the mean of the binomial, remember, is n times by p. The n is 12, the p is 0.25, so the mean there is 3. The variance, Laura, can you just please, what's the formula for the variance of the binomial distribution? Anybody? NPQ, yeah, or NP1 minus p, whichever way you want to say it. So that's 12, that's your n, that's your p, that's your q, or your 1 minus p, times those together, and you get the answer for that one. That means that the mu here, that's the mean, that's the expected value, that is 3. Sigma is the standard deviation, that's the square root of the variance. So I've rewritten the question here. All the mu's are the mean, they are 3. The sigma is the square root of the variance. Work those numbers out, and you're looking for the probability x is between 1.5 and 4.5. It's a binomial probability. What values could x be between 1.5 and 4.5? 2, 3 and 4, because it could only be whole number values. That's right. So what we've got now is a probability x is between 2 and 4. If you're using tables, that's less than or equal to 4. Take away less than or equal to 1. That knocks out what you don't want at the lower end. Using tables, n is 12, p is 0.25. We were told that at the beginning. You can look up those numbers in your tables and you can get a final answer out. Okay? So the process of that one, if it's a binomial distribution, you know that NP is the mean. It says 1 mark for that 3. You know the variance is the NPQ, as Bethany said, or the NP1 minus P, whichever way you want to say it. It says 1 mark for that 2.25. There'll be 1 mark for getting down to this point here, basically substituting in those things. 1 mark for realising actually that's just 2, 3 and 4, because you can only use whole numbers. And then there'll be 3 marks for getting down and doing that bit there to get down to the final answer. So effectively there's 1 mark for that probability, 1 mark for that probability, 1 mark for the answers. If you didn't want to use the tables, you could have worked out the probability of 2, the probability of 3, probability of 4, and added them together. So that question is out of 7 marks.